Okay. Good evening, good morning, good afternoon. Cheers, everyone. I hope all of you have grabbed your coffee mugs, juice mugs, tea, whatever you have grabbed. But yes, I hope you all are excited and doing well. Like equally, I am excited. So yeah. Okay. So I hope my voice is audible, loud and clear. Everybody is out there. Now, one thing that I want to say before I kick off this session is that I hope you will pay the complete attention today. The reason I'm saying is this is going to be a very interesting podcast, one of its own kind on my channel. The reason is the guest we have, he's one of the person that I am looking forward to hear. I am equally excited that what we can do best for the communities. He's the one who have actually inspired me to work and bounce back for the community. You know, many a times I have been repeating this that motivation you can get from anyone, but it takes discipline to keep that motivation going. And for today, what I'm going to say you all is that we are made of goodness, and our guest is the simply definition of this goodness. We are made for love, that we all know. We are made for all the beautiful things that you and I know. But the guest today have inspired me to say that we are made to tell the world that we are not outsiders, and that we welcome each and every single one of you to contribute to the community. Today, I have one of the finest organization who are doing great for the communities. The name is as simple as Gina, and Gina is a neural search framework that empowers anybody to build SOTA and scalable deep learning search applications in minutes. But I don't want to take the credit, and I want to explain about Gina more. What I'm gonna introduce the developer relation lead Alex with all of you, who is gonna talk us about the Gina project, what are the opportunities for the students, and the most interesting part, we are gonna know about him that how you as a student, as an active contributor to open source project, can contribute to the Gina. Now, the most important part, while I bring up Alex on the screens, please make some loud cheers for Alex and the team Gina who has helped us to do the podcast today. Hey Alex, how are you doing, man? Thank you
Hey,
so much
GS,
for
I'm good,
grabbing your
thanks.
slides. Cheers, man.
Cheers, man. Woo, I don't want to spill this coffee.
Not at all. So, Alex, first of all, in Indian tradition, I want to welcome you and the entire Gina team to our platform by saying namaste. Thank you so much
Namaste to
for
you too.
accepting the request. And what I want to say you, have you ever thought of like working at Gina, meeting so much of contributors and interacting with a lot of students across the globe? Have you ever thought that this Indian guy coming straight out of Rajasthan would be hosting you for the podcast named GS?
It's funny, I knew it from day one, GS. It's like this vision came to me.
Thank you. Just jokes apart. But how does it feels, Alex, to be the developer relation lead at Gina, and what you are doing at Gina? Please let us know about. Everybody's excited. I hope the messages are pouring, and everybody is there excited to hear you. So why don't you tell us about yourself, that what you do at Gina and how Gina is empowering the open source projects?
Sure thing. So I'm the developer relations lead at Gina AI, and I really love my job because it's a mix of being able to get hands-on with technology, get my hands dirty with some real Python code and machine learning stuff, but also open my big mouth and just talk to people all the time. So that's a lot of fun. The job of developer relations is
Mhm.
basically our engineers, they do all the hard work, they make all the wonderful software. We're the pretty faces. We make it gorgeous and attractive to the community. And we
Right.
engage with the community, help them use our software, and thus make our software better as well, because we're always happy to take contributions from every community member out there.
Awesome. And I always believe that when we are talking about open source and contribution for the community, it takes a lot of discipline to keep it going. So, can you tell us about one ingredient that Gina uses that's make it stand apart from all the other open source project?
That's a good question. I'd
Mhm.
say we have a great lineup of products, but then, of course, I'd say that. I'd say
Awesome.
it's all about the community. It's all about reaching out, building those connections. Like our Slack community, our engineers just respond like that most of the time. We've got so many cool people in there, and we're building it up all the time.
Right. And exactly, I was looking for that. And before we jump on to our product discussion, I want to make an announcement. And with your respect and permission, that we have asked the people to participate and win some swags. So I just want to make it loud and clear for everyone. Guys, please feel free to ask the question for Alex or for me. And some of the interesting question towards the end, we'll pick up three random winners who will be quite active during the podcast, who ask a lot of questions to Alex. So my work is easier. And hence, you are going to stand a chance to win some exciting merchandises from Team Gina itself, rightly delivered at your doorstep. So feel free to use the comment section, ask the question, and stand a chance to win some swags. But before you go out and start pouring your questions, do check out all the links below in the description of this video. Go and give a start to the GitHub repo of Gina. Fork it, join their Slack channel. It's very easy and knowledgeable. And do check out all the product links that I have mentioned in the description below. So go and check them out while we are discussing them as well. So Alex, as we are talking about our uniqueness of the product, why don't you tell a couple of offerings that anyone like who wants to explore with Gina, because they can get started. And obviously, and as I heard that we are talking a lot about this word AI nowadays, so why and how we can make our life better by contributing, or is this something that every developer should look for to make their future better, and this is going to be the future technology going ahead for the developers?
It's going to be a future technology. There are always lots of different future technologies. So I'm not going to say every developer should learn AI. There's still so many other things out there, like front end, like systems. It's like, the world is turning into a giant computer. So there's more than just AI. But AI is really cool because it means you can be damn lazy. You don't have to do the thinking. You don't, for me, when I build a search engine, pardon me, I just rely on like some plug and play AI modules to do all the hard work for me. In fact, I barely even touch the machine learning code. It's all wrapped up, it's all simplified, at least in Gina. But how I got into programming is I was lazy. I had these problems I had to do manually, like, oh God. Like, for example, when you're applying for jobs, writing cover letter after cover letter, and they're all the same. Ugh. So I wrote a generator for cover letters. You plug in some info and boom, you'd get it in PDF, in Word, on your clipboard, ready to go. And I think AI really accelerates that because you're not just throwing code at a problem, you're throwing a brain at a problem. So quite complex stuff that you can't really write code for. For example, classifying Amazon reviews. Is it positive, negative, sarcastic, happy? Writing code for that? Ugh, forget it. But throwing a deep neural network at that problem, yeah, that's just the right thing for the job.
Right. And I guess, somebody has posted something for you who I guess is the part of one of the communities from China. And I love this code, and I can't resist myself to go in the end and say, Shreya is mentioning that AI is really cool because it means you can be damn lazy. And that is stated by Alex. So I guess, Shreya, you got that attention of mine at least. So one gift is on your way for sure. Hey guys, we have our first winner. I don't mind going in the end, but yes, that's what something we have. So Alex, would you love to explain a bit more about this? Already you have though said that AI means getting your brain to code, and look, Shreya has mentioned that you can be a damn lazy. So
Yeah, I
in
mean, you
Gina,
talked
it
about
is
me being
making the developers like
100%
me.
good earlier, but no, I'm
Mhm.
100% lazy. Lazy gets the job done. I think
Right.
Bill Gates or someone mentioned, he'd hire a lazy programmer over a hard-working one because a lazy programmer thinks about the problem and automates it.
Right. Okay. And what I have what I can say is that Shreya, for you, please feel free to DM me or Jyoti on the Slack. Just reach out to Jyoti on Slack, or if you want to reach out to me for the gift collections or the swag winning, just let me know offline. Just reach out to me by doing a chat or leave the comment, and we will reach out to you. Having said that, let's take ahead. And Alex, before we jump on to some of the audience question, I have one request. Why don't you tell our viewers about Dockery? That is one of the Gina's offering. So can you just please let us know about Dockery, that what exactly this product is all about?
So I'm actually going to cover that in my deck and the
Okay.
notebook that we're going to use as well. So you can
Okay.
all code along at home if you feel so inclined. But in short, Doc array is a Python data structure for unstructured data. When I say unstructured data, I mean stuff like strings of text or images or videos, anything like that. And you would want to use this if you're building a machine learning application. You need a standard data type to feed information in and out. And you can use this in any of your Python projects. Totally free, totally open source.
Awesome. And I guess following up to that part, Shweta has one question, that what skills do we need to get started with Gina?
I'd say if you want to use Gina or Dockeray and some of our other products to build your own search engine for any kind of data, you're going to need intermediate level Python. You don't
Mhm.
really need machine learning experience, and I'll go into that, why you don't need it, a little bit later. Why you too can be damn lazy like me. We'll start a movement.
And
But
I
sorry, just to add on to that, in terms of contributions, we are putting together a whole bunch of good first issues on our GitHub repos, because I've built some examples that I'll show you in a minute. And my Python it's okay. But my HTML, my JavaScript, my CSS, oh, it sucks. So if someone could write some beautiful front ends, I would be eternally grateful.
No, definitely. And on that side, if you ask me personally, I am even bad at doing the code. Means after mosquitoes in this world, if I give a chance to kill anything, that would be coding for sure. Because that is not cup of tea for me. And that's why I had a huge respect for the developers who write even a single line of code, because they are making our life easier. And that's the reason I personally seek this motivation from every single developer who is writing some code, that you guys are doing wonder. And trust me, they are doing really, really tremendous tasks. So a huge respect for all of you. And I believe, Shweta, you got the answer correct, that what you have to do is just start learning Python. Reach out to Gina's GitHub. You already have some of the great first issues marked. Just go start solving. And what I would say, the best way to contribute is to get started with it. As simple as that. So, Alex, next thing is, what do you have for all the viewers? Do you want to share some screen, or do you want to throw some lights on anything? Stage is yours.
For sure. I'll share away.
Yeah.
Okay. Screen. Da-da-da-da. Okay. So
Okay.
let's
Yes.
get
So
this show on the road. So, yeah,
there we go.
today we're going to build an AI-powered fashion search engine with one of Gina's new products, Dockeray. And as I said before, Dockeray is the data structure for unstructured data. So in this deck, we'll go over, what is what is search, what is neural search, and how does it all work? How does the neural net behind all of this actually do its thing? And after that, we'll dive into some of the code, and we'll share notebook links. So in this notebook, you can open it in your browser. You can play with the code, edit the code, run the code, all within your browser. Don't need to install anything except a browser. Cool, let's get started. Quick content warning, there's some cute and not so cute animals ahead. So if you're animal phobic, be warned. So who am I? I'm Alex CG, Developer Relations Lead for Gina AI. I love open source, NeoVim, coffee, beer, and science fiction, especially Star Trek. Not really into sports. I've never understood the point. It just seems like glorified tidying up to me. Put the thing in the thing. And I don't like having to use a mouse. I'm a keyboard junkie, a terminal junkie. I normally live in Berlin. I'm not going to disclose my actual location today because Joe has told me not to, time and time again. I think she's worried for my safety that someone's going to put a hit on me. I'm on Twitter at AlexCG, and my GitHub is AlexCG1. Be warned, on Twitter, I swear a bit and I smack talk NFTs. So, fair warning to you all. Cool. So, what are we going to do in this presentation? We're going to build a simple AI-powered search engine for fashion images. And simple means we're not putting anything on AWS. We're just running it in a notebook. Yeah, because it's a short video. We don't have time for all that stuff. I will go into it a little bit later, but we won't focus on it. And you don't need much knowledge of machine learning to do this. And all of it will do with bits and bobs from Gina AI. So Gina AI is a startup in Berlin. We've got offices in Shenzhen, in Beijing, and teammates in India, Spain, everywhere. We build cool stuff with Python and machine learning, and we're all about open source. Every last one of us, we love it. And our range of products in our ecosystem, all of these are completely open source, by the way, free to use, free to change, free to do whatever the hell you like with. So Dockeray, which we're going to be using a lot today. So with Dockeray, you can build a very simple neural search engine using documents and document arrays. We'll see that in the code. And with FineTuner, you can take this AI-powered search engine and you can improve the model behind it. Let's say you want to search images. Well, you'd use a general image model. Great. But if you want to search images of cats and dogs and monkeys and chihuahuas, okay, they're dogs, pandas, then maybe you'd want something more highly specialized. And that's where FineTuner comes in, to go the last mile. And then if you want to scale this basic search engine up into a real world product that you can scale, you can put on Kubernetes, AWS, serve via a RESTful API, that's where Gina comes in. And then nobody wants to write all of this, the steps in a pipeline by hand. Nobody really well, maybe some weird people want to manually integrate every machine learning thing into Gina by hand. I don't. I rely on Gina Hub. So that's a whole bunch of plug and play components you can chain together to form your neural search engine. And in some of the examples I've built, you can build this thing in under 100 lines of code because you're just using one-liners that do some plug and play stuff. So first up, what the flip is neural search? I keep talking about it, but what the flip is it? Well, first of all, what the flip is search? So, I mean, usually we all think we know what we're talking about when we say, I'm going to search for something. There's a text box. We tappity, tappity, tap, type stuff in, smack enter, get a page full of results. Things like Twitter, LinkedIn, Amazon, Yahoo, Alta Vista. There's some other search engine, but I can never remember what the name is. But really, search is about so much more than that, you know? Every time you search in your app store, that's search, because of course it is, duh. But then chatbots are a kind of search as well. You type in a query, and instead of getting a whole page of results, you just get one result back. And you can also think about similarity search, which is what we're going to go into today. So I could upload a PDF about machine learning, and if I had a data set of lots of machine learning papers, I could find the closest paper to that. So being able to search any academic paper in your archive by giving it a similar paper. Or things like Shazam, that if you want to find a Beyonce song, you upload the Beyonce song and you get more Beyonce songs back because Beyonce has Beyonce's style. Same with videos. same with images. Imagine a shopping site where you could take a picture of your favorite shoes, upload it, and find similar shoes. A great use case for similarity search. So now that we've gone into what is search, what is neural search? So neural search is just search plus neural networks. And neural networks can sound kind of complicated, but you're using one right now. Even babies use neural networks because it's just the lump of meat in your head bone. You've got a neural network in there. So we're doing the same thing, but instead of atoms and a lump of meat, we're using bits and chips. And now we'll go into a little bit about how it all works. And this is not going to be complicated. It's going to be really dumb. Anyway, and red alert, everyone. It's animal time. So let's look at some pictures. We could stay here all day. I think this would just be a really entertaining video and get loads of views on YouTube for GS if we just look at cute animal pictures. But we must move on. But as we can see, they're all cute. They're all puppies. Half are puppies, half are kittens. One looks like a snowball. They're just adorable. And now we can, put them on a graph, because why not? What goes better than cute animals and mathematics? So, yeah, we only really have one axis to go with. They're all equally cute, right? Or, do you want to tell one of those kittens they're less cute than another one? I didn't think so. We're saying they're all equally cute. So cats on one side, dogs on another. We're going to keep it simple and build up from there. And now let's look at some pictures. Yeah, I warned you. These are apparently animals. The top two are apparently cats, and the bottom two are apparently dogs. The one on the bottom right, I'm really not sure about. More of a hellhound, but yeah, your mileage may vary. And now we can put these on a graph as well. But we really kind of need another dimension, don't we? Because on the x-axis, we're going between the cattiness and dogginess. And on the y-axis, we're going between ah and ah. So yeah, 2 dimensions now. And this is where some definitions come in that are useful in, the presentation, because we'll be using the terms, but also widely used in machine learning. So first up, we've got the dimensions, the cute, scary dimension and the cat-dog dimension. And the point at where one of these animals is called the embedding. And because it's a 2-dimensional graph, it's just 2 dimensions. And yeah, I spaced these out a bit so you can actually see them all quite well, because I know your life would be much worse if you couldn't see these beautiful little critters. But really, they'd be a lot closer together. The whole thing here we'll just call the index. And now, a challenge for all of you at home. And, if you think you know the answer, type it in. Or send an image of another, type it in. So let's get a new image and find something similar. And the question is, where would this fit? And I know it's tough, but yeah, type in your answers, everyone. Is it ah and cat, or ah and dog, or a combination? Let's see how ridiculous this gets. We're not giving away swag for typing in this. We'll give swag for real questions. Okay, so obviously it goes down here, right?
So we have a couple of answers for you.
Oh, you tell
People
me.
are saying, or somebody just said dog plus, or Rishita said dog.
Oh, that's good. Was that Shreya?
There was one more interesting reward, that is fluffy dog.
Yeah, I'll take them all as valid answers. But yeah, see, everyone knows this. So why would I even go into it? And I'll go into why I would go into it a bit later. So we found the closest match, 2 cute little snowballs. So how did we do that? It's a mystery. How dumb do you think we are? But it's because we've grown up looking at pictures of cats and dogs in real life, in cartoons, in static images, lots of different breeds. It's like we know a dog, we see a dog, we know a dog, even if it's a different breed. We have that understanding in our head. We have a mental model, and every animal we've seen, every cat or dog we've seen, has been embedded into that mental model and shaped that mental model. And that's exactly how the neural network works. A neural network on a machine is trained on, say, pictures of cats and dogs. At first, like a baby, it's told, this picture is of a cat, this picture is of a dog. And over time, it looks at more and more and more of them, so it gets the idea. And then, you test it. You show it a picture of a new cat or dog, and you go, hey, is this a cat or a dog? And if it's wrong, you say, nope, and it tweaks itself, and then it gets better and better and better and better. So, yeah, it's just the same as your brain. Your brain's made out of meat and carbon, and the neural network model is made out of, well, electricity and neurons, digital neurons. And I couldn't find a really good picture of a neural net, so I just went with a really retro chip. So in short, neural search uses embeddings from deep learning models to find similar things. That's the key takeaway. Remember, embeddings are the points on the graph, and the deep learning models are like the different brains you would use. For example, if you wanted to find some French phrases that are similar, I couldn't do that because my brain isn't wired that way. But if I pulled out a French person's brain and put it into my head, and if I didn't die, then I would be able to do that. So you can think of the deep learning models like the brains. So we used the example of cats and dogs, and just now I used French phrases. But neural search can search pretty much any kind of data that you can feed into a computer. So text, images, audio, video, 3D meshes. Hopefully we'll have a notebook up demonstrating that soon, in the next week or so. And also stuff like amino acids. One of our community members built a search engine just for those, which is really cool. It has little rotating molecules and stuff. But in short, if you can feed it into a computer, and if there's a deep learning model that can understand it, and there are a lot of deep learning models out there, yeah, you can build a search engine for it. Can you search for true love or the meaning of life? Well, it's early days yet, and we live in hope. So the advantages of neural search versus traditional search. Number one, it's semantic. So it's all about the meaning. So let's say I have a product catalog. I have built a basic Amazon shop, and I've got text descriptions of all the shoes on offer with a color field. Now, in a basic search engine, if I type red, I would get the red shoes. But would I get all the scarlet shoes, all the crimson shoes, all the vermilion shoes, all the very dark pink shoes that look red? Well, no, because it's only looking for the word red. So with a traditional search, I would have to write the rules, like other words for red are blah, blah, blah. But with semantic search, with neural search, we're using these brains. They have these mental models. They just know it as much as we can know something. And like humans, it can work with all data types. We work with sight, sound, smell, taste, all of these, though people say I have very bad taste. And, well, unlike your own brain, we have loads of different plug-and-play modules. So you can pull out your English-speaking brain, swap in a French-speaking brain, pull out your cat and dog recognizing brain, put in a car recognizing brain. I think that's the type my dad has in his head. So historically, there have been challenges in actually deploying these kinds of things, because if you've done anything with machine learning, you'll know these libraries are complicated and often have a lot of dependencies. And if one of them has a dependency of, say, TensorFlow 1.1, and the other one has a dependency of TensorFlow 2.3, and don't quote me on this because I don't use TensorFlow, it's just the example that always comes to mind. But yeah, they're not going to play ball well at all, because you can't really install two versions of TensorFlow in the same environment. That's one of the things that Gina solves. And optimization in terms of speed, in terms of development time, in terms of result quality, that's another area that Gina shines in. So in short, the mission of Gina AI is to provide an open source neural search ecosystem, letting anyone search for any kind of information with high availability and scalability. So yeah. Next up, well, first of all, are there any questions?
We have a lot of questions, Alex, to be honest.
Okay.
So we can take it towards the end, no problem. So you can continue.
All right, let's do that.
Yeah.
So yeah, as I said, today we're going to build a simple fashion search. Unfortunately, I broke the code for the hosted example, which is more complex. So the hosted example, you can use text to search for fashion items. You can use images to search for fashion items. So text to image or image to image. But I have to fix this. So hopefully in the next few days, it'll work again. And all of these are examples.gina.ai. And all of these will have good first issues if you want to contribute, especially with front-end work. So we won't be looking at these too much today because they're fully fledged, big working things. We're going to set our sights a little lower. So this is one of our blog posts. Well, blog post / notebook. So a notebook lets you just run Python code in your browser. And yeah, we will go through it. I'll bump up my font size a bit. So yeah, we're going to be using Docker to do this. As I said before, so many times now, it's a data type for unstructured data. It's very Pythonic. You can store any kind of data inside it. And it allows anyone to process, embed, search, recommend, store, and transfer data. So we're not going to go into everything today. This is just going to be simple, but I'll go into how we can build it up later. Most of this is in a video. And if you go to our YouTube, then you will also see we've got the cute fluffy animal video somewhere as well from Jack. Yeah, so a lot of this stuff is from videos that I wrote. Yeah, let's go into some stuff. Let's get our hands dirty. So first up, we'll just do some basic configuration. So we're going to store our data in the data folder. The data we want to play with is JPEGs. We're just going to use 1,000 images for now, because otherwise we're going to be here all day. Machine learning is great, but it can take a while. We are going to, later on, we're going to use a query image. We'll go into that later. Plot embeddings. This actually shows us the graph of where the brain thinks everything fits. We're gonna, whoa, hang on. I do not remember enabling that. I'm just going to turn that off. Colab has some cool Easter eggs, and I recommend you try Corgi mode and Kitty mode. I'm not going to do it here because otherwise we'll be even more distracted. And we're going to give it a URL that it can download the data from. So the data we're using here is from Kaggle. Kaggle is a great place to get free and open source data sets. So we're just going to use the fashion product images small data set. This actually has a whole load of files in there. like thousands and thousands. The full fashion image search on the examples page I showed you, that looks at all of them. But we're just going to look at a few because time and lazy. Right, Shift Enter. Yeah, run, because who wouldn't trust anything that I write? If it tells you I'm stealing your social security data, it's just a joke. So we're going to install Docker Array. And because we're working with images and not just text, we're going to install the full version, because images sometimes need a few more libraries to do stuff like resize or recolorize that really help with the processing. So it's downloading now. Boom, boom, boom. All right, and we're done. So next up, we're going to import a couple of classes. We've got the document class, which, as I said, that can store any kind of data, and it's a primitive data type, and the document array, which is kind of just like a Python list, but for documents. And it also has some extra features that make life easier. Shift Enter, because as I said, I don't like the mouse. I'm only using it to scroll. We're going to download the images. Yep, done. And we're going to create a document array. Now, I could write a for loop, go over every file, but we are lazy. So we have the from files. Earlier, I set data path to data / anything. Oh, that's handy. / anything.jpg and max docs to 1000. 845 documents. And let's have a look. So I really love the plot image sprites. So we can just create a very quick image to see what we've got. So as you can see, we've got a lot of different things in here. We are going to pre-process it, because if you're feeding data into a deep learning model, you want it to be all the same kind of shape, all the same kind of color depth, all of these things. So yeah, first of all, we're going to turn that image into a tensor. And a tensor is like a graph structure. And then we're going to set the shape. Images are actually 60 by 80 pixels. Normalize all the colors and switch the color axis. And like I said, I don't know much about machine learning. I don't really know why we do that, but PyTorch likes it, and we're using a PyTorch model. So that's the function to pre-process, and now we'll apply it. And again, we don't have to write a for loop. We can just go docs.apply, and it'll do it to all of the docs. All right, so yep, they've all got an ID, MIME type, and that's JPEG, tensors, and URIs. The URI is the file name. We'll install Torch Vision. So that's the PyTorch library for understanding imagery. And this is the brain, so to speak, that we're going to use. Or rather, it's a collection of brains. Because who doesn't just have a collection of brains lying around in their closet? One for every day of the week. Dum-de-dum-de-dum. Another thing about these neural network models is they are pretty big. Now I'm running this in a notebook. You can also run this on your own local machine, no problem. I would recommend having a lot of memory or setting a swap file. And yeah, all right. Because machine learning, it does require quite a bit of compute. Because we're using Google Notebook, Google Colab, and all of this is hosted, we don't really have to worry about it ourselves. GS, you need some background music, man. Times like this. And if you want to use Dockeray, it works on Linux, on Mac. If you want to use it on Windows, you'll probably want to install WSL2, Windows Subsystem for Linux 2. That's 2. Okay, we'll use the GPU if it's available, because the GPU, well, the graphics chip, if you think about your eyes are dealing with graphics. So a GPU makes it much quicker to deal with imagery and anything involving imagery, or just big complex data. All right, so now we'll import Torch Vision, and we'll choose one of our models. And this model will be ResNet 50, and we'll use the pre-trained one. And ResNet is a state-of-the-art neural network for computer vision. So image classification, image recognition, all of that cool stuff. And now we'll generate embeddings. As I said before, the embeddings are like the places on that graph where all the animals are. So the brain will look at all of these images, and it'll try to work out what's similar to what. Because even if it doesn't know what they are, it can look at common features and say, okay, this looks like something that you would wear on your top. It has 2 short sleeves. This is also looking like that. And it matches 2 t-shirts. It doesn't know they're t-shirts, but it knows they're similar. And now one of the cool things we can do that I always really like, we can plot the embeddings. So yeah. So I promised you a graph, and we already built the graph. It's just working out how to plot it at the moment. So this step, you don't need to do it, but it does look cool. So I always like to do it. Okay, so here we are. We can actually open this in a new tab, so we can see the whole thing. Or you know what, we can just look at the whole thing here. It's being a little slow. So yeah, we've got here is it done now? No. We've got a 3-dimensional graph of how similar it thinks each thing is. Now, ResNet 50 is actually playing with a lot more axes than just 3. But yeah, trying to fit a 50-dimensional graph onto a computer screen isn't really that straightforward. So we can, I thought I was spinning it. Oh, well. Oh, okay, so these are like the IDs of the different things. We can see the bags and things are all clustered together. Tops, shirts and things. So yeah. Oh, okay. Can we do? Oh, yeah, we can zoom. Okay. You can tell how much I play with our own products. I don't even know what I can do with them. So yeah, so shirts and stuff here. It's not perfect because, as I said, it's pre-trained. And it's pre-trained on loads of different images. Cars, birds, teapots, people. So it can't really specialize in clothing, but it can get a general idea. All right, we're going to stop that because otherwise it'll just hang the notebook. Stop. It'll throw an error, but errors schmerrors. All right, so now earlier we set a query image, so query.jpg. We're going to get that image now because I would love to just store it with the notebook, but Google Colab doesn't let you do that. So every time you start this notebook, it's with a blank slate. All you've got is the notebook, no other files. So thanks, Google. So yeah, we got the image with wget, and this is the image. So we're going to feed this image in and say, we want to find images similar to this. And we want to find them in here, in this graph. So we are going to put the query image into a document array because we built a document array earlier. All of these are in the document array, the index document array. So we want the same thing on both sides. So we'll throw the query image into a document array now. Boom, done. And we'll apply the same pre-processing that we did before. You remember the resizing, the recoloring, just so, again, we're comparing apples and apples, and there's less room for confusion. And all of this is quicker because we're only doing it with one document instead of about 800. And once again, we'll do the embedding. So we need to know where this image would lie on that big graph we built. Because if we want to find something similar, we need to see what's around it on the graph and bring back those. Yep, so it shows we've done that. And again, pretty quick. And we're going to say, just give us the top 9 matches. Right? So that stored them as matches. And if we want to see the results, we can do that. So as you can see, it's not bad. It's not throwing back images of shoes or bags. It's always shirts, tops at least. But as I said, this model is not trained on clothes. So maybe it's not always looking at the shirts. These are all very similar, but which bits of them are similar? The guy, the color of the shirts, I don't know, his jeans? His jeans are clothes, but that's not meant to be the main image, right? And this is why we'll go into fine-tuning a little bit later. But yeah, it's not bad. Could be better. Once again, we can plot those embeddings. And it was much quicker this time because we only have a few. And they look very spaced very far apart, but that's because this is a zoomed in version. And we're not seeing all the places where all of the bags and the shoes would be. So where's interrupt? Cool. So yeah, so as you can see, we've just built a really simple fashion search engine. It'll take one image and throw back similar images. Now, in the real world, we would want to do several different things. So first of all, as I said, this is not fine-tuned on, well, the main item of clothing in an image. It's just looking generally. So if we wanted to improve that, I don't have time to go into the code, we would use Gina Fine-Tuner. So with Gina Fine-Tuner, you can take one of these deep learning models. It could be a PyTorch model, a TensorFlow, a paddle, and you can fine-tune it. So you can think of it like if your kid has learned farm animals and you take it to the zoo and ask it to pick out a zebra or an elephant, it's not going to do very well. So a fine-tuner educates the model more and tests it more. So like a kid learning at school, it'll come out with a better understanding of its domain, or in the case of a kid, the world, one would hope. So that's a finetuner.gina.ai. It's pretty simple to use. We've got notebooks on our blog to go into it. So you can track the experiments. So this one covers fine-tuner. This one covers fine-tuner. Actually, this here is the notebook we're using just now. And yeah, all of these are notebooks. You can run the code in your browser and use the code to do whatever you like. So another thing we would want to do is we would want to build this into a real world application. It's a similarity search. It's not a bad similarity search, but it only runs in our notebook and it only runs on one machine. And there's no RESTful API. So we can't really integrate it into like Amazon 2.0 that you decide to build in your garage. If you wanted to do that, you'd need something a bit beefier. So for that, you would typically use Gina itself. So Gina, the base level of Gina is document array. But with Gina Search, Gina Neural Search Framework, you can take what we built and you can scale it up to different machines on AWS, on Google Cloud, locally in Docker, anywhere you like. You can give it a RESTful API. You can have several encoders running at once to make things a lot more efficient. You can run it on Kubernetes. You can do loads more. And of course, if you don't want to write the code, you would use Gina Hub. So in all of my big fully fledged examples at examples.gina.ai, for example, something like meme search, please work. Oh, I've broken my own code again somehow. Happy days. See, I'm not just a lazy coder. I'm a really bad coder. Or a bad DevOps deployer. I think something's gone down on my AWS. So it's not my code, it's AWS. Thanks, Bezos. But yeah, so Gina Hub, so all of these things like ResNet, where are we? This really powerful state-of-the-art deep learning computer vision model. If you wanted to integrate this, if you wanted to build a fully fledged search system on your own without Gina, you'd have to manually integrate this. And then maybe you want to change the model, use a different model entirely. Well, then you'd have to completely integrate that and write all the glue code to do so. With Gina, you can just use Gina Hub. So with one line of code, you can swap out, say, clip image encoder for image torch encoder. Yeah, image torch encoder, I believe, is more or less what we're using in ours. Let's just search ResNet. Okay, yeah, it's image torch encoder through using torch vision. But it's not just the encoding. You can build up the index, so you can store that like on disk, or you can store it in Postgres, or we're working on a lot of other database backends. If you're working with text, you can break that down into sentences with just one line of code. All of these cool things. You can load videos. You can build a ranker to rank the results differently. You can encode audio. You can break PDFs down into images and text. You can do loads of different things. In hell, if you wanted to build something that wasn't a search system, you could even just use these to do that. So yeah, there's a lot we can do to build upon this thing, on this really basic search example. And we can do all of those building things with other Gina products. So we can go from this really basic proof of concept thing to, yeah, the next Amazon, the next Shazam, or the next whatever you think of with these cool open source products. And the cost to you, free. So yeah, that's my talk. Just coming back to the slideshow. We'd really like it if you could join us sometime for our engineering all hands. So we just had it yesterday. It's every month, the second Tuesday. It's on our meetup page well, just search Google for Gina Meetup. And yeah, it's a summary of what we're up to, tips and tricks. And we're going to be doing a whole load of other upcoming events, both online and offline. Not sure we'll be doing anything in India, but Berlin, we've likely got some things planned, and China as well. So we're always looking for new places to work with our community members, to build up our community, make them feel more welcome, hold amazing events, and all of that. And yeah, if you want to know more, you can find out more about Gina at get.gina.ai. Join us on Slack. And throw us a star, as GS said. We're on all the usual places. As I said before, where am I? I'm Alex CG on Twitter. I don't use LinkedIn because I don't own a suit. So yeah, that's basically it from me. And I'm more than happy to take any questions you have. Thank you.
Thank you. Thank you so much, Alex. Means definitely when you showed up that 3D graph, my mind was something into that matrix mode. It was just flowing towards it. And I hope all of the, I was reading the chat and people were equally excited to hear that. So let's jump on to some of the questions that people have asked for you. Now, the first question coming from Abhijay says that, Alex, what are your thoughts on AI OS? Like an operating system which has an ability to predict the next actions. Do you think Gina or any other organization will do that in future?
Well, first up, Gina is about giving you the tools to build what you want to build. So we wouldn't be building like our own search engine or our own OS because we want to give you the tools to build stuff. An AI powered OS, I could see AI powered components of an OS for sure. Like you have that now in your phone's keyboard. It's doing predictive text and it's using a neural network to do that. Fully AI powered OS, a lot of AI stuff is written in Python, which is great for AI. It has a load of good libraries. But for an OS, you want really good systems level stuff. That's why things like Linux are written in C. And I guess for future writing OSs, I don't know systems programming for Jack, but writing some like in Rust, a systems level language, would probably be a lot better. But yeah, certainly components like text prediction, handwriting recognition. I think Apple is doing a lot of image recognition in their camera and photo stuff. Like Google Assistant is doing all of that. So that's more or less what I would predict. I think an OS should be, the simpler an OS is, the fewer attack vectors it has. And especially with AI, because it's a black box, yeah, I wouldn't trust it for everything. You know, I don't want my computer deciding which of my files are important. I want me deciding that. This
Right.
neural network.
Now, I guess the best takeaway I would take from this part is that Gina is giving you the tools. You just use it and build whatever you want to build. As Alex was mentioning in his presentation, that if you want to be the next Amazon, don't think and sit in on a table. It just start with a dream. You dream for something. People are there to help. Like Gina is giving you the tool set. Who knows? Next is you who is going to build that smart and intelligent OS. So all up. This is another question Ishita has asked. Is there any way to apply for Gina, apply to Gina as a front end developer, some junior?
Yep, just go to jobs.gina.ai. A
As
good way
simple
to
as
get your foot in the door is to make a PR, so make a pull request. And as I said, we are going to be putting up a lot of good first issues for our examples. So keep an eye on those.
right. And I guess I have already pasted the GitHub link, Slack channel is there, Twitter link is there. Reach out to the people and you would be able to seek the help the best you can. Or rest, you reach out to Alex. I guess he'll be always there to help the best he can.
Oh, no, no, no. Don't
So
reach out to me. Reach out to the Gina community. Because as I
that's
said,
easier.
I'm lazy. And
Yeah.
if you reach out to the community, we're not just helping one person, we're helping everyone, because everyone can
Right.
read those answers. Everyone can see a question and not feel scared about, oh, should I ask a question? Will I look stupid? Am I going to offend the engineers? No. Ask the question. That way everybody feels more confident.
Right. So thank you for that. Next question is coming from Sairam, who's asking Alex that can we use AI to automatically code the program we want without writing single line of code by a programmer? I
So
don't know.
you can write
Mhm.
programs without a single line of code. There are plenty of no-code platforms. Um, I remember using Scratch, which is aimed at kids, but there's Node-RED, which I think is for IoT. A lot of that is just drag and drop. AI powered, I don't know anything with no code, but if you know some code and roughly what you want to do, then GitHub have GitHub Copilot, which you start typing and it'll predict the rest of the function or the class. I haven't used it myself yet, but I think you have to sign up and get on a wait list. But yeah, search for GitHub Copilot or no code programming or low code programming.
Right. Thank you, Sairam. And the next question coming from Shlok, he's asking that in neural networks, if we mention more number of patches or the batch size, do we always expect to have a great accuracy, or it could decrease the accuracy as well? Any comments?
So this isn't exactly my specialty. Like I said, I don't know much about neural networks because I'm lazy, but up to a point, from my understanding, if you do it too much, you'll get something called overfit. So that would be like teaching a kid about pictures of cats and pictures of dogs. But you show them the same images so many times, it just gets imprinted. And then they're not looking for general features anymore. They're just remembering this specific image is a cat, this specific image is a dog. And then when it sees another one in real life, it won't know that that's a cat or a dog because it's only got exactly what it was shown.
Right. I hope Shlok, you are able to get that. And Shlok is asking one more question, which is says that what is the purpose of visualizing in the 3D movable fashion?
First up, because it's flipping cool, but also it lets you see, it gives you a little peek into the mind of the neural network. So you can see at a glance, if it's just a random mix of bags and t-shirts and shoes without any rhyme or reason, that's not the model we want to use. If they're all roughly clumped in the right areas, you can go, oh yeah, that's fine. And this is especially useful when you're fine tuning, because if I'm fine tuning, I would want greater separation between these things. So there's less fuzziness.
Right. Right. I guess we'll take one or two more questions because we are already exceeding your time, Alex. But with your permission, just last few questions.
Okay.
Sairam has a question. Can we run notebooks in GitHub?
No, but you can run GitHub in notebooks.
Yeah.
So Google Colab offers a way to import GitHub notebooks. The way I write all these notebooks is I write them in Jupyter Notebook on my own machine locally, first of all. Because if I write them directly in Colab, Google, they love to build lots of cool new products, but they also love to kill their babies as well. So maybe this time next year, Colab won't be around and my notebook's gone bye-bye. But if I make it on
Right.
my own machine, then host it on GitHub, and then import that into Colab, A, it'll be around if Colab goes. B, it's in a GitHub repo. So my colleagues can, and any of you can submit PRs to it, and we can all improve it together. Because Colab is called Colab, but I don't see any collaboration going on there.
Right. So one of the last questions coming from Gokul, he's asking, how is Gina helping enterprises?
So Gina is helping enterprises the same way it helps everyone else. We're providing a really good tool set. In the future, we may have some stuff specifically for enterprises. Like so many commercial open source projects do have these product offerings aimed more at enterprise than general users. But that's something we're keeping in mind.
Right. And that's pretty much about the Q&A because of the constraints of time. But still, if there are questions that we were not able to answer everyone during the live, reach out to Gina's Slack channel. It's simply slack.gina.ai. Reach out there, ask your questions out there. The community is there to help you. Do reach out to GitHub of Gina. Just give some stocks, use it, and provide your feedback, write your comments. The most important part is everything is for you. And I don't think that community work should stop. Do share your good works, do share your thoughts on Twitter, reach out to us on Twitter. We'll be there to help you. If you're still not able to find anything, do text me personally, and I'll be more than happy to share all the possible links that I have. And why not? You can easily reach out to the community to help you the best. So last but not the least, one thing that I want Alex you to just simply pass on the message about the Gina bootcamp for all the contributors. Can you just summarize in just few words what it is all about and what anybody can expect from there?
So we've recently built a new thing for anyone wanting to learn to use Gina called, Gina Bootcamp. So if you go to learn.gina.ai, there's a structured course for you to learn the basics about Docker A, Gina, Hub, Fine-Tuner. And you can take quizzes. You can get certificates that you can share online, so on your socials. And if you complete a certain amount of these, you'll get swag. So it's win-win. You get smarter and you get swag.
Right. So basically, like all the winners, one Shreya has already got one. I'm up for the two more winners, and that I'm just gonna talk in a minute. But having said that, go and participate in the Gina Bootcamp, learn, contribute, and automatically swags will be there for every individual who is gonna go and attend the bootcamp, attain certain criterias. Or last but not the least, it's not about the swag. It's all about learning and building a good work for yourself. Gina is there to help the best way they are doing, and it's our responsibility to take the good words, spread the words, and it's not about, I believe, a tech or a non-tech contribution. It's all about doing good, whatever the best you feel. Like if I take on to myself, I'm not good in the coding, but I can be the voice to reach out to the right people. So do that. It is also one of the contribution that you are doing for someone. So be that person who wants to bring the change, and options are numerous. So that's about our session today. And we have
Sorry.
our two, yeah,
If I can
please,
just add one more thing,
yeah, please.
it's about swag. At the end of the day, if you're applying to work at Amazon or Microsoft or Gina, they're not going to want pictures of your wardrobe and all your swag t-shirts.
Right.
They might not even want to see your CV. We at Gina, we care about your GitHub repo. We want to see a wall of green that you've been contributing to open source, or even just playing around with open source yourself. That's the key at the end of the day. It's about getting your hands dirty. It's about learning. The swag's just a bonus.
Definitely. And I guess with that, definitely, as we promised, there are two more winners. Shreya is the one, and there are two people who were quite active during the chat. And so, Sairam and Abhijay Jan, congratulations, at least for today. You are the three lucky winners. Do reach out to Jyoti on Gina's Slack, and she is going to help you that how you can claim the swags for today's show. So congratulations, Sairam and Abhijay Jain. If you're not able to reach out to Slack, just reach out to me on Twitter. It's just simply RSCA Sharma. Reach out a comment. Do comment on the like this video. We will reach out to you. And having said that, so Alex, two requests, or I would say the two asks from my side. First would be, how does this feel to just continuously have 1 hour? It's a 70 minutes long session that we have done. So how was your experience, and any piece of advice that you want to give to all our viewers?
Well, it's been a lovely experience. My throat is dry and I may need a beer now, but yes, it's always a pleasure speaking to people. I've got a big mouth. I don't like keeping it shut. So, and yeah, speaking with community members is the best of all.
Thank you.
Last bit of advice, go out there, get your hands dirty. If you're just getting started, find something that annoys you and that you might be able to fix with code. There's a really good book if you want to learn Python called Automate the Boring Stuff with Python. That's how I got started. I have no computer science background. I'm just a self taught geek. So if I can do it, anyone can. So go out there, hands dirty, play with code, do cool stuff.
Thank you. Thank you so much for that piece of advice, Alex. And last but not the least, before you leave the stage, can you please ask our all viewers to please subscribe to my channel as well? So it would be a great favor if you say that.
Yeah, man, it's like you paid me to say this earlier, right? So yeah, everyone go subscribe to GS's channel. He's a cool guy. I don't know. What do people say? Smash that subscribe button.
Yeah, that's
I'm
all.
so ancient,
That's
I don't know these things.
thank you so much, Alex, for being here with us. And thanks to the entire Gina team as well for accepting my request to be on the podcast. We literally learn a lot of things, and it is boosting me up to spread the good words. I hope I would be able to pass on this message to a lot of contributors who are willing to code, who wants to contribute to the open source projects, and I'll be more than happy to get it connected to the community. Thank you so much for inspiring me and many others. And literally people are have enjoyed the session, and the comments themselves says that this was my first session, and they are like, thanks for organizing learn and something really cool. Open source is love. People are talking and cheering it out throughout the session. I could see the audience. So thank you so much, Alex, for being here with us. Thanks to the entire Gina team for accepting the request on the behalf of team Cheers with God. Thank you so much, Alex.
Thanks, everyone. Have a
Hope you had
wonderful
a great
day.
day. Take care, man. Thank you so much.
Thanks. Bye bye.
Thank you. Bye bye. And for all of you guys out there, I hope you all really enjoyed the session. Stay tuned, like Alex said. Smash that subscribe button because that is what your job is. My job to bring down some exciting videos for you. This was the first giveaway. Stay tuned for something exciting coming your way very soon. Don't forget to hit that bell icon, subscribe, Cheers with Gaurav, and don't forget to hit that bell icon so that you are notified whenever the new video is up. Thank you so much, guys. Take care. Be with your loved one. Keep learning, keep hustling, and more importantly, love your loved ones. Thank you so much, guys. I'll see you within another exciting video lined up for you.